Okay, arc length and area of a sector. We did sectors in geometry.
You never taught us that.
Yes. I'm not expecting you to remember 100%. I'm expecting you to go, oh, we did do something like this. Okay, so a sector is a portion of a circle. And actually, I'm going to put fraction of a circle. Because of the, it's a fraction of a circle. And the reason I'm going to do that is because we're going to talk about like how it relates to 360. So is theta a fraction of 360?
Yeah.
Yes, because it's part of it. Yes. A sector is divided by 2 radius. And it cuts an arc length, which we call S. It says arc length. You will also hear it called sector length. I think I probably call it sector length more than arc length. So there's 3 pieces to this. There's an S, there's an R, and there's a theta. Did we already draw this picture this week? Yes. What was the formula I gave you?
S equals R theta.
S equals R theta. And what's special about theta?
It's
In radians.
right.
Always in radians. So if you're given an angle in degrees, you must put it into radians. Okay, so give the length of the arc cut off by a central angle of 2 radians. So that's theta equals 2. And a radius of 4.3. So S equals 2 times 4.3, which is
8.6.
This is inches.
Probably.
So 8.6 inches.
Does this get more complicated?
Uh-huh. Well, it can't get much more complicated. You have theta equals, S equals R theta, so you can solve for R, you can solve for theta, but other than that, it really can't get much more complicated. You have to draw your pictures and make your scenarios correctly. But other than that, it can't get much harder. So, guess what we're going to bring back? We're going to bring back our Ferris wheel. And we're going to have a person at position 1, ending at position 2. Ferris wheels are not going to go anywhere, guys. So this would be our theta. Now, are these supports necessary for my picture?
No.
No. So if you want to get rid of the supports, can you get rid of them? But you probably need to make like a straight line down here so you know it's not sitting on the ground, right? Okay, so we have a model of George Ferris's Ferris wheel. Recall that the diameter of the wheel is 250 feet. So D equals 250 feet. Theta is the central angle formed by the rider that travels from the initial position. Actually, they call this P sub 0 and this P sub 1. Doesn't matter if I call it 1 and 2. No, but they call it 0 and 1. Find the distance traveled if theta is 45 degrees and if theta is 105 degrees. So we have two. We have A and B. So if I only go 45 degrees, how far do I travel? So what is that? What am I finding? Part of the sector am I finding?
S.
S. Okay. So S equals what?
Theta.
R theta. So we probably need R, don't we? Which is 125 feet. It's half of our diameter. And before I can do these, I need to make both of these into what? Both of these angles into what measure?
What?
Radians. Okay, so 45 is one we know, yes? So 45 is what? Pi over
6.
45 goes into 180. How many times?
Oh,
4.
sorry.
So here, S equals pi over 100, well, actually just 125 pi over 4 feet, correct? Because I don't think 4 goes into 125, does it? So, without a calculator, that is your answer. On your test, that is your answer. If you're checking your answers with the back of the book, put that in your calculator. Okay? So 125, or 105 would be 105 pi over 180. And then you need to reduce. I was thinking 5 first.
Yeah.
So 21 and 36.
Got 3
Okay, so then I have 7 pi
over 12.
over 12 times 125. 125 and 12 reduce.
You?
Do they? I'm asking you.
No.
No. Okay, so 7 times 125, right? I should have wrote S equals. So 5, carry a 3, 775 pi over 12 feet. So again, without a calculator, we're just going to leave it as 775 pi over 12. So again, can I make that much harder?
No.
No, I can just give you weird angles. Basically, the next one they tell you the minute hand on the clock is 1.2 centimeters long. Just 2 significant digits. How far does the tip of the minute hand move in 20 minutes? Okay, so make your clock, right? So does it really matter where I put it? It just says 20 minutes, right? Okay, most of the time with the clock, we'll probably go straight up because it makes more sense. Where would 20 minutes be?
Not very far.
They'd be at the 4, correct? And the 3 is here. So the 4 would be here.
Yeah.
Now it wasn't 20 degrees, was it? It was 20 minutes. So we have 1.2 centimeters is R. We need to figure out, because we want S, we need to figure out theta. Well, every 5 minutes on a clock is how many degrees?
5.
30? No, it's 30.
What'd you say?
It's 30.
Every 5 minutes on a clock is how many degrees?
30.
30.
Oh, yeah.
Right? Because 360 divided by 12 is 30. So if I got 20 minutes, so every 5 minutes is 30 degrees. So 20 minutes is how many?
What do you mean?
No, 120.
120 degrees. So 120 is 60, yes? So that's going to be over 3. What's my numerator going to be?
120 is.
5.
So it's.
No,
No, it's 2. Right?
4, isn't it?
No, it's 2. Because it's 1 less than a whole.
Oh,
So that's theta. So I have theta and I have r, so am I good?
What's R?
1.2 centimeters. So S equals 2 pi times 1.2 over 3. Probably should reduce, shouldn't we?
can we?
3 goes into 12, doesn't it?
Mm-hmm.
So it's 0.4. So S equals 0.8 pi centimeters. And it said to 2 significant digits. So 0.8 pi. So what, 2.5?
Mm-hmm.
So approximately 2.5 centimeters.
Why is it 1.2?
What?
What do you want over 1.2? Or what do you have 1.2? It's R.
That's R.
Oh,
One- Okay. This, I love this. Okay, so if we're talking anything like far away. So if I'm standing on the earth here, every time I draw this picture, I think of like the Little Prince. And I have the moon clear out here. And I can't do it without. And if I would say, draw this sector, and this would be of some huge circle. See that? So this is still sector length, but is that sector pretty straight because it's so far out there? From us to the moon, that radius is huge, right? So since this radius is so far out there, that diameter of the moon is going to be almost straight because of the fact of that circle. The orbit of the moon is huge. Does that make sense?
Oh, yes. I didn't know that you
Yeah.
asked.
And that's why I was like not explaining it very well. Does that make sense to you guys? So you'll have things where they talk about like this radius or the distance to the moon is, I don't even know how far the distance to the moon is. That's sad. I should know that. It's in one of your questions. Talks about like the radius of the earth. Oh, you're supposed to find the distance of the moon or something like that. But the distance to the moon would be here. And this, the S, would be the diameter of the moon. So you can draw these pictures to larger scales and things change. Okay? Is what I'm trying to get at. So another example, and again, it's not any harder, it's just you have to think of it differently. This example is always the most fun to do. A person is standing on the earth, okay? So, person standing on earth. Here I am standing here. Looking up in the sky. They notice that a 747 jumbo jet is overhead and it sustains an angle of 0.45 degrees. Okay, now here's your plane up here, and some random person just notices that the angle from the back of the plane to the front of the plane, because we have that capability, right? Is 0.45 degrees. I just love that question. Like, you just happen, like, I had my surveyor equipment outside with me that day, and the plane stood still long enough for me to get that measurement. I think the plane would drop. I don't know. It's like buying...
In their whole life to figure that out.
Yes, yes. Okay, and if the length of the jumbo jet is 230 feet long, so it's 230 feet long, and that's the jet. How far up in the sky is it? So what's the altitude? So it's to the nearest 1,000 feet. Okay, so we need the altitude, right?
R.
R. Altitude is R. So what is 230?
X.
It's S. Because there is this little what? Curve right here? S is 230. And if it's almost straight with us standing on the ground and planes, fly, I guess we're going to figure out that how high it's flying. It's going to be almost straight, isn't it? Okay. So we want R. So if S equals R theta, and that's the only one I will ever bring up to you, what's R equal?
S over theta.
S over theta. Again, we're remembering S equals R theta. It's easy. It's multiplication, right? We know basic algebra to move things around. So what's S?
230.
230. And R has to be in radians. So that would be
I
point,
over 4.
well, it's 0.45.
Oh.
So it'd be 0.45 pi over 180. And we can reduce that, which we will reduce, but just remember that it was 0.45. Okay, so if it's 0.45, then it wouldn't be pi over 4, it would be pi over 0.004, right? Would there be two decimal places?
What?
If it was 45, it'd be pi over 4, yes? But there would be how many decimal places? 2? So I have 230 over pi over 0.004. So then I have to multiply by the reciprocal. So 0.004. I think I have one too many zeros. Two decimal places would just be point, wouldn't it?
Mm-hmm.
Let's check. But I think I had too many. It would help if I didn't put it in the way we say it. Oh, we are so wrong. Okay, so
That's 0, 0, 2.
0.0025. I was right on my zero zeros. And it says to the nearest 1,000 feet. So we're just going to put it in our calculator. So 230 times 0.0025 divided by pi. That is so wrong. Yes? Why is that wrong? Why do you know that's wrong?
Because it's definitely not 0.183 feet
Right.
off the ground.
Correct. Okay. So do I need parentheses? I don't think I should need them because it should just go straight across, right?
Yeah.
What's going wrong?
Well, isn't it's 0.45 pi on does that make a difference? Does it?
Yeah.
Well,
Because I shouldn't be dividing by pi. I should just be what? Well, no, that would be right because that's divided by pi. Let's just put it in the calculator like this. We got a calculator for a reason, right? What am I doing wrong? What am I doing wrong? Because we still would divide by pi.
you flip the 180 and that 0.45 pi.
Because we needed the reciprocal of that. I didn't reciprocate it. That's what it was. Because dividing it gave me that, but then I needed to reciprocate that. And I didn't. Okay. So when you have something like this, we have a calculator, we're going to need it anyway. Would we just kind of do it? Okay. So now we have to have parentheses. And I'm just going to put it in exactly how I have it. 230 parenthesis 180 divided by parenthesis 0.45 pi 2 parentheses, right? Okay. Much better. Much better? So R is approximately 29248.5, and it said to the nearest 1,000 feet. So if you gave me this answer, I would take it, but the book says nearest thousands, so for checking it, what would be the nearest thousands feet? 29,000?
Yeah.
Now, the formulas we used in geometry were more involved because you guys didn't know what radians were. So you had to convert it into radians in your formula. And we don't have to do that. We did it here because it was just a weird thing, right? Okay. So area of a circle is pi r squared, yes? So we're going to have a fraction of that. So area of a sector is A equals 1/2 because a sector kind of looks like a triangle, yes? R squared because it's part of a circle, correct?
Mm-hmm.
And then the fraction of our circle depends on the theta, doesn't it?
Yeah.
So 1/2 r squared theta. Now, that is not why those things are there. well, kind of, but not totally. But we're going to remember it because a sector kind of looks like a what? Does it kind of look like a triangle? Yes, so it's 1/2. R squared comes from area of a circle, right? And theta is our fraction of our circle, is our central angle. And theta, again, has to be in what?
Radius.
Yep. So I don't know, other than setting these up, I don't know how they can get hard. Like, none of the problems we've done so far are hard, are they? No. You might have one where they like, how many miles? Actually, that last one probably did say miles, and we have it in feet. So we'd have to divide it by what? 5,280? Okay, so make sure you're answering what they're asking, basically. So a sector is formed by a central angle of 15 degrees. So theta equals 15 degrees. And it has an area of pi over 3 centimeters squared, because it's area, right? What's the radius? So what am I going to do with my formula? I'm going to deconstruct it, right? Do you guys want to move the formula around before we plug things in?
Yeah.
Okay. So if I have area equals 1/2 r squared theta, how do I move the 1/2 over?
Subtract.
Not divide, not subtract,
Multiply.
multiply. Multiply by 2. So 2, there's no addition, subtraction, you can't. Unless you're doing the whole thing. So 2a equals r squared theta. Then what?
Divide by theta.
Divide by theta. And then take the what?
Square root.
The square root. So theta equals plus or minus the square root of 2a over theta. Probably not going to be the minus. What?
That's theta equals Ms. May.
Oh, that's r. Sorry. Probably not going to be the negative, because can a radius be negative? No. Measurements cannot be negative. They can go backwards, they can go left, right, up, down, north, south, east, west, but they can't be negative. So it's always going to be the positive, but I'm just going to make that there. So r equals the square root of 2 times a. What's a?
No, it's
Pi over 3. It looks weird, but it's there, right? And what's theta? Can I put 15 degrees in here?
no, it's
Have to do in radians, right? So 30 is pi over 6, so 15 would be pi over what?
8.
12? 15 is half of 12?
Oh.
Or 30?
Good point.
So pi over 12? And again, I could have multiplied it by pi over 180 and reduced, yes? But if you know 30, should you be able to figure out 15? Yeah. Okay. So I have to multiply by the reciprocal. So I have 2 pi over 3 times 12 over pi, all square rooted. So pi's reduce. 3 goes into 12, 4. So I have the square root of 2 times 4, so what can I bring out? Or what is that? 2 square root of 2 centimeters. slow motion. There is one more example about a lawn sprinkler.
So it's like, oh,
It's like what?
hold on. Yeah.
You good?
Mm-hmm.
Okay. Do you want to do the lawn sprinkler one real quick? It shouldn't take much. It says the lawn sprinkler is located in the corner of the yard. So it's the corner of a yard, so we're going to assume it's at what angle? Or 90-degree angle. Okay. So the sprinkler's right here, and it sprays out 30 feet. And when a sprinkler, it rotates, so that makes a what? A sector. So 30 feet would be the radius.
Mm-hmm.
What's the area that it covers? So A equals, you guys can remember it?
1/2 r squared theta.
Okay, 1/2 r squared theta. Theta has to be in
Radians.
radians. Okay, 1/2. What's r?
30.
So 30 squared. What's theta?
Uh, 90.
90, so it's
Oh. Pi over 2.
pi over 2. It might help you before you even start these problems to put them into what? Radians?
Mm-hmm.
Okay, so 900 pi divided by 4. So 4 goes into 9 twice. Carry 1, 2, carry 2, 5. 225 pi feet squared. It's about 707 feet. So, can these be hard? The hardest part is going to be drawing your picture,
Yeah, true.
because the formulas are not hard.
Stop asking me big questions I can't answer.
I know you guys are like not being able to function today.